All right, hello and welcome to the 2.4 notes filling out edition of Advanced Geometry with Mr. Staines. In this lesson, we're talking about algebraic reasoning and how we can use those properties to help solve an equation. All right, so we're building towards writing proofs, ladies and gentlemen, which is one of the tougher things we're going to do this year. Sections 2.1 and 2.2 talked about deductive reasoning, logic, flowing step by step through a process to get to an answer. And that's how you want to think whenever you're writing a proof. Now, this section is just talking about, okay, how are we going to fill in the proper steps when it's things that we kind of already know, but we need to learn how to justify them. So, for instance, the algebraic properties, I know you guys have learned these in the past. We just want to clarify everything in this section to help you reason deductively. So for instance, when you add something to both sides of an equation, so we start out with A equals B, well then we're going to add C to both sides of an equation. What allows you to do that? The addition property of equality. Same thing when you subtract. There's a subtraction, multiplication, and division. So you start out with some two things that are equal, and then you do something to the left-hand side of the equation, and that same thing to the right-hand side of the equation. That balances the equation. Those are actual properties of equality that you learned back in the day. Just got to be careful whenever you can't divide by 0, so be careful. And then if you multiply both sides by 0, you're changing the actual value of what's happening. So you want to be careful when you multiply or divide. That's really not going to come into play too much for us. Substitution. This is a property that we're going to use a lot this year. This is a powerful statement here. If A equals B, that means you can substitute or replace A for B anywhere throughout an expression. All right, so let's take a look at what it's going to look like. Example 1, justifying steps. So I know you guys can solve this equation. So now let's take a look at what it would look like if you were going to prove it by justifying the steps of it. So what I would do first would be to add 4x to both sides of this equation. So that leaves me with 7x plus 2 equals 23. Now, our reason for that, let me back it up first. Whenever you start out with whatever they are giving you, I just said it, they're giving it to you, so that we refer to as the given. So the given is going to be your first step in all these justifying and proofs. All right, so in the second step, what took us down, so this was our first line, this would be our second line. So what got us to that point was the addition property of equality. So that is what we write on the right-hand side here, the addition, and I'm just going to abbreviate POE, property of equality. Then from there, of course, we would subtract 2 on both sides, leaving us with 7x equals 21. So there's the third line. And how did we get there? Well, we subtracted. So subtraction, property of equality. And then, of course, our final step would be to divide by 7. So that takes us to x equaling 3. So there's their final line. And you might not even have the work like I'm doing, like this step and this and this. So it might just be like where my arrows are. But regardless, what got you to that point now is the division property. So I know you know how to solve this equation, and then in this section, they just want you to use things you're familiar with, like this equation, and learn how to justify it with the properties of equality. Now, an old friend, the distributive property, the old mailman, they might have taught it to you back in the day like this. So if you have a number outside a set of parentheses, it's understood to be multiplication, and you can go ahead and take that value outside and distribute it amongst the things inside the parentheses, whether it's addition or subtraction. All right, this will be a little less sloppy now. I'll just uncover here. So again, we're going to start out with our given information. That's always our first step. And then, of course, we have the -5 outside the parentheses, so we can distribute that. So take the -5, multiply it by both of the things, and we end up with -35w minus 40 equals 30. And of course, you can probably guess what we're going to have to do now. We're going to have to add 40 to both sides of the equation. So that's the addition property. And then finally, after that, we're going to divide both sides by negative 35. So W is going to equal negative 2. So these reasons are the properties of equality. And then our new friend, which is an old friend, the distributive property, anytime you're going to use that. All right, example 3. Now, sometimes in this section, they're going to work in some literal equations. And a literal equation, when you get to algebra 2, you'll use them, you'll solve them, I should say, a lot. And it's just an equation with multiple variables like we see here. You get a raise at a part-time job. This is a good scenario here. Use the formula P times the quantity R plus 1 equals N. And it defines your previous wage, percent, your new wage. Solve the formula for R. So now R is hidden inside the equation. That's why literal equations are important. They show up on SATs a lot. Solving this equation for R. All right, so to do that, of course, start out with the given information, which is your formula for figuring out your percent raise. So now to solve for R, first thing we want to do is we want to divide or distribute the P. You could divide. This is just one other way to do it. So they're distributing the P, showing you the distributive property, and then are going to subtract P on both sides of the equation. Because remember, we're trying to isolate R, so we want to get rid of this P, so we're going to subtract it on both sides of the equation. And then, of course, we're going to divide by P to get R by itself. All right, so then if you wanted to know what your raise was, you could just plug the numbers in that they give you. You go from $7.25 an hour to $7.54 an hour. There, you'd have a 4% raise. So again, this mainly here is talking about starting with this formula and rewriting it to solve for a different variable. All right, pause the video here. We'll talk about the monitor progress when you come back. And back again. So hopefully you look a little something like this, my friends. First one, you got to distribute, then subtract and divide. All right, now let's talk about this for a second. You haven't really gotten to this point yet. This is very important, so pay attention, put your ears on for the video, for this part of the video. Whenever you have a situation like this, we have variables on the same variable on the same side of the equation. So we're taking negative 10b's and negative 6b's, and we're making them negative 16b's. So you might think, well, that's just, I'm combining, I'm adding or subtracting, but that's not a property of equality. Let me say that again. That's not a property of equality. Rewind the video. That's not a property of equality because you didn't cross an equal sign. You just cleaned up two things on the same side of the equal sign. So some books will call it combining like terms. Our book refers to it as simplifying. We just made the right-hand side look a little nicer. So that is an important note in this section. And then, of course, the next step was subtracting 12 on both sides. So since we crossed an equal sign, that's subtraction property of equality. And then, of course, division to cross an equal sign as well. So that's a division property of equality. All right, and some other properties we have of equality we're going to use a lot this year as well. Reflexive, symmetric, and transitive. You might think, what do I need a property to say A equals A for, or that AB equals AB, or that angle A equals angle A? You're going to see coming up in the next 2 or 3 chapters, we're going to use the reflexive property a lot. Symmetric. When I have 2 different elements here, if A is B, then I can just reverse it and say B is A. It's good for segments and for angles. And then transitive is when you have 3 elements. You have A is B, B is C, so then I can link A with C. So the reflexive is just 1 element, symmetric is 2, and transitive property is 3. All right, so now how are we going to use them? You reflect a beam of light, determine whether DBA, D to B to A, this one, this angle, is equal to E to B to C, this angle. All right, and watch how it flows. First off, start out with a given. We're given that, in this case, and they would have to tell you this step before you'd even start. So 1 and 3 are congruent. All right, that's cool. Well, look at our next step here. Measure of angle DBA, D to B to A. I'm getting a little messy here. Let me back this up. So D to B to A, this whole big angle is made up of angle, sorry, let me back it up, is made up of angle 3 plus angle 2. Well, what property did we learn in the past that allows you to take two smaller angles and add them up to equal a bigger angle? And of course, that is the angle addition postulate. So I had this little angle plus this little angle equals the entire angle. Okay? And then, this is an important one as well. Since 1 equals 3, anywhere I see a 3, I can replace it with an angle 1. And when I replace something, there's your substitution property. All right? Now, how do I transition? Well, let's see. If DBA is 3 plus 2, DBA is 1 plus 2, and then measure of angle 1 plus 2 by the same logic would equal EBC. So here's angle 1, here's angle 2. Together, they make EBC, the angle addition postulate again. So anytime you're taking two angles and setting them equal to the bigger angle that they create, angle addition postulate. And then final step, here's the example of our transitive property. So if DBA is 1 plus 2, and 1 plus 2 is EBC, then I can link DBA with EBC by the transitive property. All right, try the last couple monitor progress questions. All right, friends. So here you go. First one is example of symmetry. We have two different elements. We have a 6 and a 7. When we just flip them, 6 is 7, 7 is 6, symmetry. 34 is 34, just one element, reflexive property. And three elements here. If 1 is 2 and 2 is 5, then 1 is 5. So there's your transitive property. All right, signing off on 2.4.